Then what remains is x plus 2. So the limit of x plus 2 as x approaches 2, we will substitute x with 2. So 2 plus 2 is equal to 4. So this is the first step. We solve the slope of the tangent line. Okay, the second step is to get the equation of the tangent line using the point slope form. Y minus y sub 0 is equal to m times the quantity of x minus x sub 0. Okay, we have the x sub 0 which is equal to 4 and the y sub 0 which is equal, the x sub 0 is equal to 2 while the y sub 0 is equal to 4 and the slope is equal to 4 as well. So y minus the y sub 0 is 4 equals to the slope which is also equal to 4 times the quantity of x minus the x sub 0 is equal to 2. So minus 2. So y minus 4 equals 4 times the quantity of x minus 2. 4 times x is 4x. 4 times negative 2 is negative 8. And then transpose this one, positive 4. So negative 8 plus 4 is negative 4. So the equation of a tangent line is y minus 4x minus 4. So you can see that on our graph, the graph of a function is a parabola opening upward, and at x is equal to 2, you can see that the tangent line exists here, which the equation is equal to y equals 4x minus 4. Another example, we will find the equation of a tangent line to the function f of x is equal to square root of x at x is equal to 4. So again, our x sub 0 is equal to 4. We don't have the value for y sub 0 yet, or the f of x sub 0, but we do have the f of x, which is very useful for our to get the slope of a tangent line. So the limit of f of x is equal to this one minus the f of x of 0, which is unknown from this point, over x minus x of 0. X of 0 is equal to 4. As x approaches to x of 0, which is 4. So again, the x of 0 is equal to 4. Now let's solve the f of x of 0 or the y sub 0. So the y sub 0 is equal to the f of x of 0, which is equal to the square root of x. And the f of x of 0 is f of 4, so square root of 4, which is equal to 2. Now we have the value for the y sub 0 or the f of x sub 0. Now we could solve the limit or the slope of a tangent line. So the limit of f of x is the square root of x minus the f of x of 0, which is 2, over x minus the x of 0 is 4 as x approaches 4. Okay, so this is indeterminate form 0 over 0. To get the true value or actual value of the limit, we should manipulate our um, equation. So to get the limit, let's multiply the numerator and denominator by the conjugate number of the one who is here, the radical, to eliminate the radical sign in the numerator. So the conjugate number is square root of x. Now it becomes positive 2, so plus 2. That's the conjugate number. So square root of x plus 2, we will multiply that both in our numerator and denominator. So square root of x times square root of x is square root of x squared. Square root of x times 2, that's 2 square root of x. Negative 2 times square root of x, that's negative 2 square root of x. And finally, negative 2 times 2 is negative 4. We could simplify this one. Square root of x squared is x. 2 square root of x minus 2 square root of x, that's 0, negative 4. So x minus 4, and then as is on the denominator, that's x minus 4 times square root of x plus 2. Now you notice that x minus 4 is common in the numerator and the denominator. We can cancel this one. So what remains is 1 over square root of x plus 2, and then here comes x becomes 4. So 4 square root of 4 is 2. 2 plus 2 is 4. So the answer is equal to 1/4. That's the slope of our tangent line. Now, since we get the slope, now we can proceed to get the equation of the tangent line using the point slope form. Okay, y minus y sub 0 is equal to m times the quantity of x minus x sub 0. So we have the y sub 0, the m, and the x sub 0. The m is the slope, which is 1/4, while the x sub 0 is 4, and the y sub 0, that's the f of x sub 0, which is 2. Okay, so y minus 2 is equal to 1/4 times x, that's 1/4 x. 1/4 times negative 4, that's negative 1, and transpose negative 2, which is positive 2. So the answer, y is equal to x over 4, or 1/4 x plus 1. That's the equation of our tangent line here. So you can see on our graph, square root of x at x is equal to 4, you can see that the tangent line exists and it has an equation, y is equal to 1/4 x plus 1. Okay, another example, show the tangent line to y is equal to 3x squared minus 12x plus 1 at the point 2, negative 1, if it is horizontal. Okay, so the x sub 0 is equal to 2, and the y sub 0 is equal to negative 11, which is this one. And then y sub 0 is negative 11. So to get the slope of the tangent line, so that's limit of f of x minus f of x is 0 over x minus x of 0. So we have the x of 0 and the f of x of 0. That's the y sub 0. And then we have the f of x, or this one, 3x squared minus 12x plus 1. Okay, so let's solve the slope of the tangent line. Limit of the function 3x squared minus 12x plus 1 minus the f of x of 0, which is negative 11, over x minus the x of 0, which is 2, as x approaches the x of 0, or 2. So this is indeterminate form, 0 over 0 once again. So let's get the actual value of the limit by, in this case, factoring. So 3x squared minus 12x plus 12, the factor for that is 3x minus 6 times x minus 2. Please review your factoring because it's really useful here in the derivative. Over x, I mean the slope of a tangent line. So 3x minus 6 times x minus 2 over x minus 2. The common factor is x minus 2. So 3x minus 6 as x approaches 2. So we will just substitute the value of x with 2. So 3 times 2 is 6 minus 6, that's 0. So our slope, or m, is equal to 0. So now, if we use the point slope form, y minus y sub 0 equals m times the quantity of x minus x sub 0, we can see that if our m is equal to 0, then this part is equal to 0. So what remains is y minus the y sub 0, or negative 11, so y plus 11. So our y is equal to negative 11. And we could see that really the tangent line is horizontal. So I mean, if this is the if this is y and this is the x, so at negative 11 we can see that whatever the value of x, our y is always negative 11. So it means that our line is horizontal, and yes, our tangent line is horizontal.